Page 14 of a very brief look at calculus. What we're going to talk about now is U substitution, or what some of us prefer to just state as U sub. And what this means is I can't readily find the integral or antiderivative of this, and I definitely don't want to do binomial theorem of this, so I'm going to use a little U substitution. I'm going to come over here and say, let U equal the guts. But once I do that, that's going to give me U to the fourth, but I can't keep the dx with the u there, so I have to differentiate this. So du, the derivative of u, is going to equal the derivative of this side, which is just going to give me 1 dx though. Now, I have du equals dx, so I can replace dx with du. Now, I'm just going to find the antiderivative of u to the fourth, and that's going to give me u to the fifth divided by 5 plus c. But what does u equal? We noticed that u equals x minus 5. So I substitute that back in to give me x minus 5 over 5 plus c. And there's my first u sub. Not too bad. Number 2 for u sub, notice now I have to multiply product and it's to the third power. I definitely don't want to do binomial expansion of that and then multiply it by x to the fourth, so I'm going to use u sub. And I'm going to let u equal the guts, x to the fifth plus 17. So that's going to give me the integral of x to the fourth times u to the third. But I got to make this a du, not a dx, so I have to take the derivative of both sides over here. So du is going to equal something dx, and that's going to give me 5x to the fourth dx. Notice I'm taking the derivative over here and the antiderivative over here. Now, I see I have an x to the fourth over there and a dx, so that x to the fourth is going to cancel out with that x to the fourth, and that dx is going to cancel out with that dx, but I'm left with this 5. So what a lot of people do is they throw it underneath, and they divide both sides by 5, and that gives me 1/5 du equals x to the fourth dx. So now I have to take this 1 to the fifth du and bring it over here. Du, and oftentimes we put the 1/5 out front. And I don't really need that x to the fourth. It was canceled out here. It was canceled out with the dx there. So that just leaves me 1/5 of the integral of u cubed du. Now, I can find the antiderivative of that and then substitute that back in. Let's see, I add 1, so that gives me u to the fourth over 4, but I have to multiply this by 1/5 plus c. Now when I put the x to the fifth back in, that's just going to give me x to the fifth plus 17 in for u to the fourth power now, all over 5 times 4 is 20 plus c. And that was a little bit more involved u substitution. I have another u substitution problem, and I'm going to let u equal x cubed minus 1, but this time I have a definite integral. And this is actually a little bit easier if you look at it as a work-related problem. It's a little bit simpler to do this. I'm going to take the derivative of u over here, so that's du equals 3x squared dx. I can get rid of the x squared and the dx. They will eliminate, but the 3 will not. So it's going to give me 1/3 du equals x squared dx. And notice, that x squared dx will replace that x squared dx with a du. So I'm going to put u over here to the fourth with a 1/3 out in front, because I have this 1/3 out in front, of du. Doing everything I'm supposed to here. Now, I can go ahead and find the antiderivative of this and then plug that x cubed minus 1 back in, or I can rewrite the integral in terms of u. So I take that 0 and I throw it over there. For x, 0 cubed is 0 minus 1. So that's going to give me a new integral from -1 to, let me put the 1 here in, 1 cubed is 1 minus 1 is 0. Now I'm going to evaluate this definite integral in terms of the new interval. So u to the fifth, I add 1, divided by 5, but don't forget I have the 1/3 out front, on the interval from -1 to 0. So now what I need to do is simplify this a little bit further. That's going to give me u to the fifth over 15 on the open interval from closed interval from -1 to 0. And now that's going to give me something to the fifth over 15 minus something to the fifth over 15. And the values I throw in those brackets or those parentheses is 0 or -1. Now 0 to the fifth is 0. 0 divided by 15 is going to give me 0 minus -1/15. So minus minus. Let's see, that's going to give me a positive 1/15 as my answer. Let's see how well we fare using technology
on this problem. So my answer was 1 over 15, and let's see if we can achieve that using the Casio. So let me turn it on and hit the integral button, which is right here. And I'm going to type it in like it looks, alpha x squared times parentheses alpha x to the third power minus 1, close parentheses, to the fourth power.
Let's see how well we do with our calculator. I'm going to hit the integral button and type in alpha x squared times parentheses alpha x cubed to the third power minus 1, close parentheses, to the fourth power from 0 to 1. And let's see what we get. It should be 1 over 15. And there it is, 1/15.
All right, for number 4, I want to do u sub and let u equal 1 minus x, but I've already entered it into the calculator, and I'm going to hit equals. Now, if it's a radical function, it takes Mr. Casio a long time to figure it out. Sometimes I can do it quicker by hand than the computer can. So let's see here. I'm going to let u sub, so that's going to be u to the 1/5, because what's in the bucket goes on the bottom. Now I'm going to find the derivative of u over here, so that's going to be du equals -1 dx. The dx will cancel out with the dx, but the -1 has to go out front, and the du replaces. Now, I'm going to also reevaluate the interval. So I'm going to throw 1 in. 1 minus 1 is 0 for my new ending interval. And throw a 0 in over there. 1 minus 0 is 1. And now this is a little creepy because I'm going backwards. But the rule in calculus is if you flip-flop that and make it from 0 to 1, you have to put another negative in front. And notice that's going to give me positive now of u to the 1/5 du. Now I'm going to go ahead and find the antiderivative and evaluate it from 0 to 1. So I'm supposed to add 1. I'm going to add 5 over 5, so it's going to give me u to the 6/5 over 6/5 from 0 to 1. But I want to simplify that, so u to the 6/5 times the reciprocal of that. I'm going to put it out front. That would be 5/6 from 0 to 1. And let me enter that 5/6 times 1, that 1, to the 6/5 power, minus 5/6 of 0 to the 6/5 power. Now this is going to equal 0. And this is going to equal 1. So 1 to the 6/5 is just 6/5. So that final answer is just going to give me 5/6. And notice the answer just came up on the calculator, 5/6. Now I want to see if that's the decimal equivalent. Notice it didn't give me the exact fraction. It gave me a decimal. So I'm going to see what I can do with my calculator here. 0.8333333. I'm going to overload my calculator. And usually if you do this on this type of fancy calculator, and there it is, it equals 5/6. So that's approximately equal to 0.833 repetend. 0.83 repetend. They're the same answer. Sub, I'm going to let u equal 3x, which is the exponent up there. The derivative of u equals 3 dx.
For u sub, last one, what I want to do is let u equal x cubed. So I'm going to find the derivative of that. That's going to give me du equals 3x squared dx. I noticed immediately that the x squared will cancel out and the dx will cancel out, but the 3 will not, so I'm going to divide both sides by 3. That gives me 1/3 du equals x squared dx, and as I said already, that x squared dx is just going to replace that x squared dx. I'm going to also reevaluate the interval from 0 to 1 and see what happens. When x equals 0, that's 0 cubed, u will equal 0. When x equals 1, 1 cubed, well, the interval didn't change. I'm a little surprised, but pleasantly surprised. Have to bring the 1/3 out front. And this is going to give me e to the u. du now. That du goes there. I'm going to find the integral of antiderivative of e to the u. And we like this. The integral of e to the u is going to be e to the u over 3, because of the 1/3, from 0 to 1. And let me plug that in. That's going to give me e to the first over 3 minus e to the 0 over 3. Let's recall that e to the 0 is going to be 1. So this basically is going to give me e minus 1 over 3. And let's see what that equals.
E minus 1 over 3 is approximately equal to 0.5728. 0.5728. 0.5728. Let's try this one on the Casio from the beginning. Integral of x squared times e to the x cubed from 0 to 1. And yes, it matches up. It matches up. But notice you have to use the calculator to get that decimal equivalent. Most teachers would want it in exact form.